Nikola Tesla, a name synonymous with innovation, was a man ahead of his time. Born in 1856 in the Austrian Empire, Tesla's brilliance shone brightly from a young age. He possessed an unparalleled ability to envision the future of technology, particularly in the realm of electricity. Tesla's mind was a crucible of groundbreaking ideas, and his inventions transformed the world. Tesla's fascination with electricity began early in his life. He was captivated by the mysterious force that could power machines and illuminate the night. This fascination fueled his insatiable desire to understand and harness the power of electricity, leading him to dedicate his life to its exploration. Tesla's journey led him to the United States, where he would leave an indelible mark on the world with his revolutionary inventions. Among his many groundbreaking innovations, one experiment stands out as a testament to Tesla's visionary genius: the wireless lighting of a light bulb. This experiment, conducted in the late 19th century, demonstrated Tesla's deep understanding of electromagnetism and his ability to manipulate it in unprecedented ways. Tesla's vision extended far beyond simply lighting a bulb without wires. He dreamt of a world where electricity would be freely available, powering homes, industries, and transportation without the limitations of physical connections. Tesla believed that electricity was all around us, an invisible force waiting to be harnessed. He envisioned a future where energy would be transmitted wirelessly, freeing humanity from the constraints of wires and cables. This vision, though seemingly fantastical at the time, laid the foundation for modern wireless technologies that are now an integral part of our daily lives. In the late 1890s, Tesla conducted a series of experiments that captivated the world. He demonstrated the ability to light a light bulb without any physical connection to a power source, a feat that seemed impossible at the time. This experiment, conducted at his laboratory in Colorado Springs, was a testament to Tesla's understanding of electromagnetic induction and resonance. To achieve wireless illumination, Tesla employed a high-frequency transformer of his own design, now known as the Tesla coil. The Tesla coil generated high-voltage, high-frequency alternating current, which created a powerful electromagnetic field. This field, in turn, induced a current in a nearby receiving coil, which was connected to the light bulb. The bulb, receiving power wirelessly through the air, illuminated brightly, showcasing the potential of Tesla's revolutionary technology. Tesla's experiment was not merely a spectacle. It was a carefully orchestrated demonstration of scientific principles. He understood that electromagnetic waves could travel through space, carrying energy with them. By carefully tuning the frequencies of the transmitting and receiving coils, Tesla achieved resonance, allowing for efficient energy transfer over a distance. This principle, known as resonant inductive coupling, is still used today in various wireless technologies, including wireless chargers and RFID tags. At the heart of Tesla's wireless power experiment was his ingenious invention, the Tesla coil. This high-frequency transformer was instrumental in generating the powerful electromagnetic fields required for wireless energy transfer. The Tesla coil, with its unique design and capabilities, became a symbol of Tesla's innovative genius and his unwavering pursuit of wireless power. The Tesla coil consists of two coils, a primary and a secondary, wound around a non-magnetic core. The primary coil is connected to a high-voltage power source, while the secondary coil is connected to a capacitor. When a high-voltage current is applied to the primary coil, it creates a rapidly changing magnetic field. This magnetic field, in turn, induces a high-voltage current in the secondary coil. The secondary coil is designed to resonate at a specific frequency, determined by its inductance and capacitance. When the frequency of the primary coil's current matches the resonant frequency of the secondary coil, a phenomenon known as resonance occurs. This resonance amplifies the current in the secondary coil, generating extremely high voltages, often in the millions of volts. These high voltages create the powerful electromagnetic fields that enable wireless power transmission. Tesla's wireless lighting experiment was more than just a scientific curiosity. It was a glimpse into a future where electricity would be freely available, unshackled from the limitations of wires. Tesla believed that wireless power could revolutionize the world, enabling the transmission of energy over long distances without the need for costly and cumbersome infrastructure. Imagine a world where homes, industries, and transportation systems are powered wirelessly, drawing energy from a central source. Tesla envisioned a global network of power towers, beaming energy through the air, eliminating the need for power lines and cables. This vision, though ambitious, highlighted Tesla's belief in the transformative potential of wireless technology. Tesla's vision extended beyond mere convenience. He believed that wireless power could solve some of the world's most pressing problems. He argued that wireless energy transmission could electrify remote areas, bringing light and power to communities that lacked access to traditional electrical grids. He also believed that wireless power could reduce reliance on fossil fuels, paving the way for a cleaner and more sustainable energy future. Tesla's vision was not limited to wireless lighting. He dreamt of a world transformed by wireless power in countless ways. He imagined ships powered wirelessly, traversing the oceans without the need for refueling. He envisioned airplanes soaring through the skies, drawing energy from the air itself, achieving limitless flight. Tesla's mind was a boundless realm of possibilities, where wireless technology was the key to unlocking a brighter future. Tesla believed that wireless power could revolutionize communication, enabling the transmission of information over vast distances without the need for wires or cables. He envisioned a world interconnected by wireless networks, facilitating instant communication and the sharing of knowledge across continents. Tesla's vision extended to the realm of transportation, where he imagined electric vehicles powered wirelessly, drawing energy from a network of charging stations embedded in roadways. This concept, known as dynamic wireless charging, is now being explored as a means to extend the range of electric vehicles and reduce reliance on battery charging. Tesla's ideas, once considered fantastical, are now inspiring modern innovations that are shaping the future of transportation. While Tesla's grand vision of a world powered wirelessly remains largely unrealized, his ideas have laid the foundation for numerous wireless technologies that are now an integral part of our lives. From wireless chargers for smartphones to RFID tags used in inventory tracking, Tesla's principles of electromagnetic induction and resonance are at work, enabling the transfer of energy and information without physical connections. The most ubiquitous example of wireless power today is the wireless charger, found in millions of homes and offices worldwide. These chargers utilize inductive coupling, the same principle employed by Tesla in his wireless lighting experiment, to transfer energy from a charging pad to a compatible device. The convenience and efficiency of wireless chargers have made them a popular choice for powering smartphones, tablets, and other portable electronics. Beyond consumer electronics, wireless power is finding applications in various industries, including healthcare, manufacturing, and transportation. In healthcare, wireless power is being used to power implantable medical devices, eliminating the need for batteries and reducing the risk of infection. In manufacturing, wireless power is enabling the development of robots and drones that can operate without tethered power sources, increasing flexibility and efficiency. Though Tesla's dream of a world powered entirely by wireless energy remains unrealized, his legacy as a visionary inventor continues to inspire generations of scientists, engineers, and innovators. Tesla's groundbreaking experiments with wireless power, his profound understanding of electromagnetism, and his unwavering belief in the transformative power of technology have left an indelible mark on the world. Tesla's contributions to science and technology extend far beyond wireless power. He was a pioneer in the development of alternating current, AC electricity, the system that powers most of the world today. His inventions, including the Tesla coil, the induction motor, and the alternating current generator, laid the foundation for modern electrical power systems, revolutionizing the way we generate, distribute, and utilize electricity. Tesla's legacy is not merely about his inventions, it is about his unwavering belief in the power of human ingenuity to solve the world's most challenging problems. He was a tireless advocate for progress, a champion of innovation, and a firm believer in the ability of technology to improve the human condition. Tesla's spirit of exploration, his relentless pursuit of knowledge, and his unwavering dedication to pushing the boundaries of what is possible continue to inspire and motivate innovators today. Tesla's ideas, once considered ahead of their time, are now finding new life in the 21st century, as advancements in materials science, electronics, and computing power enable the realization of concepts that were beyond Tesla's reach during his lifetime. From wireless charging to electric vehicles to the development of advanced energy storage systems, Tesla's pioneering work is influencing the development of technologies that are shaping the future. Tesla's vision of wireless power transmission is now being explored in the context of electric vehicles, with companies developing dynamic wireless charging systems that can power vehicles while they are in motion. This technology has the potential to revolutionize transportation, extending the range of electric vehicles, reducing reliance on battery charging, and paving the way for a more sustainable transportation future. Tesla's work on resonant inductive coupling is also finding applications in the development of wireless sensor networks, which are used for environmental monitoring, industrial automation, and healthcare. These networks utilize wireless power transfer to power sensors and transmit data wirelessly, eliminating the need for batteries and wiring, making them ideal for remote monitoring applications. Nikola Tesla, the visionary inventor, the master of electricity, the man who dreamt of a world powered wirelessly, left a legacy that continues to inspire and amaze. His groundbreaking experiments, his profound understanding of scientific principles, and his unwavering belief in the transformative power of technology have left an indelible mark on the world. Tesla's story is a testament to the power of human ingenuity, the importance of perseverance, and the enduring impact of a single individual's vision. His ideas, once considered ahead of their time, are now shaping the future, as advancements in technology enable the realization of concepts that were beyond Tesla's reach during his lifetime. Tesla's legacy is a reminder that the pursuit of knowledge, the spirit of innovation, and the belief in a better future are timeless virtues that can continue to inspire generations to come. As we navigate the complexities of the 21st century, we can draw inspiration from Tesla's unwavering dedication to pushing the boundaries of what is possible and his unwavering belief in the power of technology to improve the human condition.